Hi and welcome to this new module on differential scanning calorimetry. At the end of this presentation, you will understand what is this phenomenon called thermal history in polymers. So this is our contents outline. First of all, we will talk about different structural rearrangements that can be found in our polymers. Then we will define what is this thermal history in polymers. And then we will see different methods that can be applied in case we want to erase this thermal history. This is a schematic view of a polymer in which we have some different chains that are distributed in the bulk polymer. It can happen that due to different storage conditions, these chains can rearrange among themselves in order to obtain a different structure. These changes in a structure can lead to a change in properties. So about the thermal history of polymers, we can see how this morphological conformation of the polymer chains happens as a consequence of a previous treatment or storage conditions. Which conditions? Humidity, temperature, or even some temporal spontaneous relaxations. What we will see in the DSC are new transitions and relaxations. These new transitions and relaxations can be positive if we are really interested in the storage process is focus of our study, or it can be negative because they can mask the real transitions that we are really interested in. So we have to eliminate them. Let's have a look to one example. In the blue scan, we can see the response of a DSC of a polymer with thermal history, and the red one is without thermal history. If we superimpose them, we can see these masking effects. So we have to know if we are really interested in them or not. If we are not interested in them, we have to erase this thermal history. And how can we do that? We have to first melt the polymer and deliberately cool the sample. That means apply a known and a specific cooling scan. Then we will apply this thermal history under known conditions. This is the cooling I was referring to, in order to obtain comparable thermograms. This can be done by different methods. We can anneal or we can quench, as we will see. In order to perform this annealing, we will first melt to erase the thermal history of the scan, and then we will apply a controlled cooling, which is quite slow, and that's the reason why it's called annealing. But you have to know that the smaller is the cooling rate applied, the more natural is the rearrangement allowed to the chains. That's very important. Let's compare it to the quenching. We will first heat and melt our polymer in order to erase this thermal history, and then we will apply a very fast cooling. This is called quenching. That what will happen here is that the polymer chains will remain trapped in a new state, primarily amorphous, even for semi-crystalline polymers. So remember what we have seen, that spontaneous structural rearrangements can mask comparable results. Then the thermal history can be found in a calorimetric scan to an untreated sample, and then we have to know if we are really interested in this thermal history or not. If we are not interested in this thermal history, it can be erased by annealing or quenching. Thanks for your attention.